right. How's everybody doing? I know it's been forever since we've done a stream, but things have been super busy, so okay, so I haven't been missing streams. Yeah, I've just been grinding on a bunch of Invoke stuff, some of the stuff I'm going to be talking about today. So a bunch of background on what I want to do today is, I've talked about this before, but Tony, who's in the chat right now, and I did a bunch of stuff on the Scavenger malware. And Hexamine pointed out that this was actually being obfuscated with this C++ obfuscator. So let me find that here. So this is actually a compile time C++ obfuscator that uses vectorization. So basically when you're using this obfuscator, this XOR string thing, you just wrap your given constant within, let's see here. Yeah, like this. You just wrap your given constant within this XOR string denotion here, and it's like a hash defined with this API. And then basically it'll do like an inline encryption of the string to make it only recoverable after performing the XOR operations. The other thing that's interesting here is that it's used by a lot of malware. So even though this project is like 7 years old and then they just fixed an MSVC regression like 4 years ago, it's still actively used by a lot of malware developers. So, and then, yeah, so let me pull up that link that Hexamine threw in the chat there. Lazy importer. So a simple and easy to use header only library to make the life of a reverse engineer much harder. Okay. So then they do, does not leave any strings in memory, does not allocate any memory, can be easily inlined, does not leave any imports in the executable, produces extremely small assembly. Interesting. Yeah, I haven't looked at this project before. Thanks, Hexamine. Probably actually make some notes today because I will be doing some like triage stuff. I'll put them just in like a doc here, notes.md, and then I'm just going to throw that other project because that's something that we can look at in the future. Not that I don't want to look at it right now, but it looks like it's primarily used for imports, which they might also be using for these projects, but there is an example at the end of the repo. It shows you how ugly the code gets. Oh, okay. Let's see here. Example output, keyword. Okay, yeah. So yeah, this is like effectively a dynamic import resolution sequence, I believe. Because this read GS keyword on 64-bit is effectively the same way to get the PEB. And then it looks like this would essentially iterate over the export address table of a given DLL in memory and then hash it, from what I can tell. I'm assuming these constants also change. So, and then yeah, looks nasty though. Read GS never lies, yeah. Okay, so cool byproduct of this research was that, so I wrote this test YAR rule when I was trying to find more of those scavenger binaries. And then this sequence basically just looks for these vector XOR operations, or like a vector move keyword. I think QU is keyword unsigned, probably like an unsigned extension. And then VP XOR, I don't exactly know what that stands for, but these are all vectorized. I didn't mean to go to unpack me. Perform bitwise logical XOR. Okay, so is this not? Yeah, they're using, oh, I think this is just the XMM version. Anyways, so these are all XMM XOR operations. And then basically I just masked the components of these opcodes that would likely change between binaries. So the cool part about this is that not only did it find more scavenger stuff, but it also found other malware families that were using the same obfuscator. So I thought that's what we could go through today and take a look at. So just for some background, in case y'all didn't read those blogs, etc., I wrote a deobfuscator in Binary Ninja for these obfuscation sequences. So let's see if I can find one in this binary, which is a scavenger binary. We just need start. This is different in here. I can't remember. CRT startup. Then we have our dispatch function. Sorry, I'm just going to set up my screen here. And then I'm going to fix this too. I like using the single function view because it's kind of more like IDA, which I'm used to. And then the DL dispatcher CRT code. And there should be, yeah, the thread is, this is the create thread that's executing the main malware function for the scavenger stuff. We won't dwell too long on this just because I've kind of beaten this to the ground. And there's actually going to be a really cool collaboration coming out about this soon. So I don't want to go over it too much. And Humpty already did a second stream on the scavenger stuff. So you ever used zdysinfo? Very helpful for understanding bytes and instructions. No, I haven't used that before. What is it? Pimmy trousers. Okay, so if we look at a bunch of these sequences here, it has dynamic function resolution, which we've looked at like a million times on stream, but that's what these hashes are. These are function hashes. And if we scroll down here, we should see some of those XOR operations. Yeah, so like this is a really good example. The HLIL kind of looks messed up, but if I look at the low level intermediate language, then we could see some pretty evident patterns here. So there's these like keyword assignments that get assigned to the RAX local variable here, which happen to be RAX registers. So if I go to like the disassembly, then you can see that's just the RAX register in this instance. And then that RAX register is moved into a local variable. I'll move this over a little bit because I know the chat's probably covering it up. And then further down here is those XOR sequences. So like that YAR rule that I wrote, like this VP XOR with those move operations. And then this will effectively deobfuscate that constant at runtime for it to be used by the malware. Hexacorn, zdysinfo, the disassembler breaks the code twice. Oh, cool. Yeah, I'm definitely a big hexacorn fan. So let's take a look. Zdysinfo. Let me just look at the page here. Fast and lightweight, x86 64 disassembly library. Okay, cool. Yeah, I might take a look at this because I was doing some stuff to see if I could optimize the disassembly of actually these specific binaries, to see if I could deobfuscate them faster because Binja gets kind of slow with these giant functions. Yeah, this is pretty cool. I know there's like 10 million disassembly projects, so it's kind of hard for me to like figure out which ones are actually useful or not. Okay, so this looks for specific opcodes, it looks like. Nice. This is pretty interesting. Yeah, I'll definitely take a closer look at this project. It looks like it would be a good learning tool. I like zdys, but I'm not sure it's the most friendly library. Lots of wrappers required to make it nice and usable. Okay, good to know. Thanks, Snow Not Decomp. Okay, so let's get back to our binary here. So yeah, so those deobfuscation sequences. So I basically just wrote automation to look for these operations within those binaries that I found with that YAR rule. And I'll show you what that code looks like. So if I think it should be headless. So I ported this to 32-bit as well. So we can probably look for some 32-bit binaries we want today as well, because this deobfuscator should work for both. It's not perfect by any means, but it works pretty well. So if I scroll down here, we can see a few different things. So we have, okay, so there's a few different things here. First, I'm running this in headless mode. So for those of you who do not have a commercial license, you won't be able to do this, but you can just basically copy paste this code into Binary Ninja and do the same thing. So it's not super complicated. But here we have the binary ninja.load operation, and we provide the path to a binary, and then we have these load options. So these are really important because these functions get like enormous. So this is a single function, and I don't know how big the function is. Maybe we can actually use the Python API to determine that. Address ranges. I don't know why it has so many different address ranges. Why is there like 5 different address ranges? Anyways, we can probably use this or this ending address. So this minus this. So it's like 167 or almost 168K, which is like huge for a single function in a binary. So Binja struggles with disassembling and decompiling these functions, but that's the reason we want to set some of these options here. So analysis mode basic. So if I go to the options here, my settings, and then just do, oh no, I think I have to do like open binary with. So let's try that. So if I go to open with options and then just like select one of these random binaries and then go to, let's see, basic. I think should work. Then you can specify an analysis mode. So in this instance, since I'm only using the low-level intermediate language, which is like one step up from the disassembly, then I only need this basic mode, and then that just works a lot faster than basically getting all levels of the intermediate language when using this headless mode, because I don't need them. And then so I specify basic there, and then you can basically specify a max function size. So here I've just used like a huge number to basically make sure that it actually analyzes all functions in the binary. And then I've disabled the PDB parsing features. So for acquiring associated types with the binary that's being loaded, and I've just disabled that because we don't really want the binary going and getting types associated with the Microsoft Windows libraries that are being imported by the binary, because again, that takes more time. And then basically I'm passing the binary view. So this is essentially the binary interface for interacting with the Binary Ninja database. And then I'm passing this to a function I've just called capture assignments. And if I look at capture assignments, this basically just iterates through every function in the binary. So it goes through every function using bb.functions. It'll acquire each basic block and get the low-level intermediate language from each basic block. It'll acquire each instruction from each of those basic blocks. I know you can do this in one line. I don't know why I like doing it that way, but I do. And then this is just checking for the architecture. So I have like 2 fingerprinting functions that will basically look for different types of instructions that are associated with the obfuscator. So if I go up here, there's this match 32, and basically this just looks for the low-level intermediate language instructions that are associated with each of those obfuscation sequences. So here I'm just looking for a set register operation, and then it has basically making sure it has a source, which means like if we look at one of these here, and I go to the LLIL, so go up one level. Okay, so here's a good example. So if I just do like current IL instruction, then we can see this is a low-level IL set register, which is effectively what that's looking for. And then if I do operands, then we can see that, or if I do like source, for example, then we can see that that's basically just getting the right side of the instructions. So if you do destination, then that's basically just saying that the destination will be an RAX register, which is another thing that I check for in the other one, not in this one, but basically it looks for source operation being a low-level IL constant. And then we look for a store operation as well. Sometimes it's a store being on the stack rather than being set in a register. And then just ensuring that this is within a certain range, so that the value constants are within this range. And then the 64-bit version is very similar, but I do check for RAX in that instance, and then ensure that these are the same there. Basically, all I do is once I identify like a batch of those instructions, then basically I'll collect a batch of those. I just call it a stack in this instance, but basically I just append those into a list, and then I'll look for the first XOR operation relative to that list, and then check if my stack or large amount of instructions are greater than 2, and then pass that stack to a process strings function. So it's pretty basic. It's like maintaining state by looking for those operations, and then it knows that the end of the sequence is there based on finding an XOR. So it's not super complicated. And then there might be a more elegant way to do this. If you know of one, please let me know, because I'd be interested for sure. And then all this is basically doing is it's taking the starting set of those XOR operations, then the ending set, and then it's XORing them together. So these keywords are basically just because it's using 64-bit integers to create a final string after the 64-bit integers have been put into a list here, which is what I'm doing here. This is just a faster way than writing this to a byte sequence, for example, in Python. If you're doing that every single operation, it's quite slow. So, and then similarly, if it's the address size is 4, which means it's 32-bit, then I'm just doing a struct.pack on the integer values that are results from those XOR operations. And then finally, I'm setting that as a comment at the address at which the sequence started. So nothing crazy, but this is kind of a lot of the techniques that I use for deobfuscating these sorts of sequences, which, it works pretty well most of the time, but sometimes it gets pretty complicated in terms of having to fingerprint the sequences. In this instance, it wasn't too bad. So if we go back here and I run this against here, I didn't realize the PDB said this, which is pretty funny. if you guys can see that. So they definitely patched the PDB path, and then it's trying to pull those from the Microsoft symbol server, which is awesome. Okay, so then let's see. So yeah, say we wanted to deobfuscate this, then I'll just run the headless one because it's set up for that. Headless, and then we'll do, what's this binary, 6C or C6? Here we go, .bin or .exe. And then it's going to be a little bit slow just because this is running on a VM. But like when I was working on this stuff with Tony, I was running this on my Mac just because it was like way faster than running it on here. But this setup's way better for streaming, so I use it on this. So as you can see, even with the simple binary parsing, it takes quite a while. So okay, so these are all the strings associated with that scavenger sample. We get things like C2s, this scavenger constant that's used to identify whether it's already on the system, more profanities. This is actually used to decrypt the binary that's downloaded from the C2, etc. So I don't really want to go into this too much just because, we've kind of beaten this to the ground already. There's 2 blogs on it, blah, blah, blah. So if y'all are interested how this thing works, you can definitely go read those. But one thing I do want to go into is that because of that YAR rule that I was using to try and triage some of these binaries, I pulled all of these from UnpackMe. Shout out UnpackMe. Shout out Sergey and Sean and OA Labs. And these are all, so if I do file, there's a bunch of P32 and P32 plus binaries. Some of them are executables. Most of them are, or no, a lot of them are executables actually. And so if I do like grep DLL, this doesn't really matter. 16 of them are DLLs, GUI, like like the majority of them are executables. So I did kind of some pre-stream work in that we didn't really want to sit around because this deobfuscator can be quite slow. And I did write these to a file if I can find them. Okay, so basically I ran the headless deobfuscator against all these binaries, and then these are all the associated deobfuscated strings. So I thought what would be fun on this stream is if we try and figure out what malware variants these are, because they are using the same deobfuscator. They don't have to be malware, but if they are trying to obfuscate their strings in some way, shape, or form, and they are Microsoft Windows binaries, then chances are it's probably malicious. But that's why we do triage in order to determine whether or not they're malicious and their actual intent. A lot of these are Scavenger, but we're going to skip those. Okay, so like for example, this 0f81 has like attack your target. I think I Googled this earlier, and I think this is from, I think some of these might be anti-cheat, or not anti-cheat, these might be cheating engines. So if I go to I think this is from Arc, which is, I don't know if this is like a shout out to Arc or that this is actually associated with Arc. This aggression level is similar to neutral, blah, blah, blah. So I don't know if it's associated with the game or what, but yeah, you got a Humpty. You're faster than my Googling skills or DuckDuckGoing skills. So if we go back to this here, so like maybe we can take a look at that. I don't know, not super interesting. Another thing I wanted to look at was this is like, I have repeats in my deobfuscator, so I need to figure out why that is, because that's definitely a bug. But if we scroll down here, then there's some interesting ones. So there's this like base64 looking sequence, and then there's like an IP address. There's like the start of a second IP address, so this might be a bug in my deobfuscator. And then if I scroll down here, we could see this base64 sequence that it looks like it might be a modified base64 sequence. So it looks like they've just shuffled around the alphabet. And then if I go up here, this is like a result of that. So this could be kind of interesting as well. And there's like IP. So this is probably a port. This is probably a version number of whatever this is. So that's probably something we can look at. But the really interesting one, I'll show you. This is another Scavenger one, so ignore that. Let's key. So this is another one that's very similar to that other, whatever that is. I won't say malware yet, but it looks very malware-y. And we have more IPs. And then again, a different, or is this the same? Let's see. It's the same modified base64 sequence for both those binaries. But let's go down here. All right, this one was kind of interesting. They're resolving like NT terminate process, crypt hash data, NT DLL. Looks like that might be, as you can see, some of these deobfuscation sequences are perfect. And then there's like this PowerShell command it looks like it's using RM force recurse on C/Windows. So I don't know if that would actually work. So kind of weird. It looks like it would probably just not work on Windows if they didn't have the privileges, etc. And if it did work, then it would probably break the system. This is more Scavenger stuff, so we'll skip that. I'll keep going. This one looks pretty interesting. It's like getting load library. Again, this is a bug in my Deobfuscator. I'm not entirely sure why there's a bunch of repeats. Virtual alloc. So we could probably take a look at that. It might be some unpacker. But let's see, I'll keep going, because there is one I wanted to show you guys that's pretty interesting, or more interesting than these ones. Is this it? No, it's still Scavenger. Yeah, this one. So this binary has like what looks like every single anti-analysis trick in the book, at least in these strings. So they're resolving all these NT functions, which is interesting. They have this debug string and direct NT API access, process information access, debug helper functions. So it looks like these strings might be associated with these DLLs, maybe. So maybe when they identify these DLLs, then they print this. But like process information access, debug helper functions, so debug help.dll, debug helper function, simserv, simple server access. And if we scroll down here, maybe I'll get this open and something that's not Vim, because these null bytes make this kind of hard to read. So yeah, let me just clean this with Python real quick, and then we'll keep going. fw log, and we'll just open this. fw close, not R. Okay. All right, let's try this. All right, that looks better. I don't think we'll actually need any of those null bytes, but okay. So yeah, so these are easy to read now. VM protect, DDK, SDK. I don't know why they'd be looking for VM protect DLLs. That's interesting. Hopefully this doesn't have VM protect. So it'll be really hard to reverse. Oh, so I can see a level 1. Damn, I should have seen that earlier, but that's okay. Okay, so if we look at some of these other DLLs, they're looking for like MS key protect. I don't know what that is. Inline syscall.exe. See, like, I don't know why they have like descriptive names for each of these DLLs, but, or no, sorry, these are actual API names. So ignore what I just said. So yeah, this is probably dynamically resolving those. So I think it's both like anti-analysis sequences and then dynamically loading stuff. So it looks like it's opening up or looking for these open pipes, named pipes, which I don't actually know if things like these drivers might, but I saw some stuff in here that I didn't think would have these open, but maybe I'm wrong. Like VMware VMX, like these probably do, because they likely have associated drivers with the virtual mouse, etc. BattleEye, I don't know what that is. Easy anti-cheat. Maybe this is just game hacking stuff. WPE Pro, memory hacker, cheat manager, process hacker. So like it's looking for all of this stuff, which is pretty interesting. VMware. So I thought we could pop this open in Binary Ninja, and then I'll run my like little deobfuscation script in there, and then we can start actually reversing this to see what we can find, to see what this is doing, because I'm pretty sure this is a loader. But what I also did was I submitted all of these against my AssemblyLine instance. So hopefully my session's still active. Yeah, so this is a crazy search string, but I was just wanting to have these ready for stream. So I'm just going to search this. Okay, so soon trademark. Can you just enum pipes from userland as a non-admin user? Yeah, I'm pretty sure you can. I think that's a good question though. I think there's probably some limitations for what they can do with the pipes, but you might be able to find their presence from non-userland, but that's a good question. But yeah, soon this AssemblyLine instance will be available to the premium folks on InvokeRE. So I've just been like running a whole bunch of tests. Tony and a few other folks, some of the mods on the Invoke Discord have been helping me test this out, just making sure that it's not going to fall over. But yeah, soon this will be available to premium folks, and then we can all kind of submit stuff and work on things together. So that'll be pretty cool. But I ran all of these Scavenger samples against the AssemblyLine instance just to see if there's any intel about them already in existence. So for those of you who are not familiar with what AssemblyLine is, it's a analysis pipeline that you can submit files to, and then it'll essentially run a bunch of services against those files. So if I do like dashboard, then you'll be able to see that there's a whole bunch of these services. They're not very descriptive, but these will basically run a bunch of different things against a given file to extract information from it. And that's essentially what you'll see in reports for all the files that I just ran against it, all these specific files. It has a bunch of cool integrations, like if I click on this, then we can see, maybe it's hard for you to read. These are from Triage Sandbox. So for example, there's like these types of activity that they'll classify as likely malicious or suspicious or whatever. And these will all be brought back to AssemblyLine. And then if I scroll down, then it also, like this PE service was able to see that it has resources and there's no languages associated with the binary, which are sometimes in the portable executable format. It has a data list resource, which is kind of weird. It has too many exports. I don't really know what that means, but it's apparently has 1,500 exports, which is definitely super weird. And then there's like this extract service that will basically like unzip files, decompress files, etc. So it's kind of like a automated triage pipeline that's quite similar to like Malcat or Binary Refinery, etc. But you just have to submit files to it. So another thing it found was this has embedded portable executables, which is quite interesting, using this Frankenstring service. And if I scroll down here, then we can see that all the files that these services extracted. So we can see the like embedded PE file that it extracted and it classified as malicious. And this does a whole bunch of operations. So we can actually probably look at the triage report for this, because I don't know what FW maybe. I know there's like information overload in this user interface, but there is certain things that are worth making note of. But if we want to go to this triage report, I can just copy this here. And for those of you who are not aware, Triage is a commercial sandbox, but they have some pretty good researcher support. So if you apply for a researcher account, you can probably get one. But just know that you're uploading files to a public cloud, of course. You get used to the visual fairly. Yeah, I'm pretty used to the AssemblyLine visual for sure. Okay, so if we look at the dynamic run here, let's see. This isn't like the file I was just talking about. This is just like a random one I picked. So let's see what we have. Okay, this actually has pretty low scores. So I'm not sure why this was classified as malicious in AssemblyLine. But let's look at one of these like 6 out of 10 behavioral ones. So it drops a bunch of INI files, which is weird. It adjusts privilege tokens, drops files. Okay, so that's what it meant, like file write within the Windows directory. This UPnP device host, which is super sketchy. It acquires these privileges. So as you can see, like the triage sandbox is pretty solid for getting a general overview of what activity is being done without having to do too much. This is like a DVD player, but why would it be obfuscated with this XOR string thing? So like it's quite sketchy. Okay, so if I go back to AssemblyLine here, TLDR, like the reason I brought all this up was because we can get a general overview of some of these binaries without having to fully reverse them using some of these external services. So for example, if I pull up this interesting binary here in our AssemblyLine instance, I know this sequence is really long, so it's just this hash, then we could see that Triage was also able to detect like a whole bunch of this anti-analysis stuff. So delete sysself, anti-vmwine, and then suspicious keywords in the PDB file name. And that's what it says. A lot of profanities on today's stream. Extracted from executable. Let's see what else we got here. The file timestamp is in the future, which is 2069, of course. And it's apparently signed. So I actually do want to check if it's actually signed, because that would be quite interesting. I don't think it is, but okay. So this looks like it's been identified as Cobalt Strike by a few things, but we'll take a look at that, because obviously the strings are probably not associated with Cobalt Strike. Behavior. I just want to see if it's signed. That's in the details tab. I can actually just pop it on a Windows box and see if it's valid. Oh yeah, it is signed. Crazy. Okay, let's see. SH Software Services Company. What are the file details? It's just a loader.exe while being signed. Yeah, cool. So that's pretty interesting that it's signed. So let's also pop back here. So that's good to know. So I'm just going to throw this in my notes. Triage. Let's see, interesting binary with anti-analysis strings and, or let's say loader.exe name. What else do we want to say about this? And it's signed. Okay. So I think we can probably, like I said, open this up in Binary Ninja and see what we can determine about this. So I'll just open Binja, and I actually already opened this, which is good because it's takes quite a while to open. So let's go from the start here, and let's go from start. There's a trap here. Let's see what it is. UD2. Interesting. Let's go back to the HLIL. And then I don't know what this would fall through to, but there's probably exports. So let's go to the triage view. Then let's scroll down here. Okay, the only export is the start function. Okay, so the start function is different than what I was just looking at, the underscore start. And then we have this giant deobfuscation function, probably kind of similar to what we saw before. So let's actually see what these look like once we deobfuscate them with our automation. So I think I have, let's just copy over one that I was just working on. xorstr deof. Let's get rid of this for more real estate. And then let's go to our triage here. Headless 32 or 6432. I'm just going to copy this guy. I should probably get clipboard support for my terminal in Linux, but that's okay. Okay, so I'm just going to run this, but instead of this, I don't think we actually need any of this. So we're just going to pass the BV to this function, and then we'll let it run. Maybe I'll enable some printfs here, just so we can see that it's working. And I'll just run this. How's everybody doing? Doing all right? I'm not seeing any output here, so maybe I have to adjust it. Capture BV. Oh, there we go. Not iterable. So, okay, so there's a problem with some of these functions. The reason, again, like that I had to make those headless adjustments is because some of these are huge. So, but we'll work through it. So, and basically when Binja doesn't analyze a function because it's too huge, then my analysis fails effectively. But it looks like we're good now. And I could, put in a try catch exception to deter that, but all good. Goma, cool. All right, while that's running, yeah, we had a super good turnout at the Invoke meetup at DEF CON. So I just want to shout everybody out for everybody who showed up to that. So thanks everybody who came out for that. Hopefully we can do some more in-person meetups in the near future. It's just really cool meeting everybody that I hadn't met in real life. It was kind of funny because I was going around to everybody and introducing myself and being like, hey, so like, I don't know what anybody looks like. So I'd be like, hey, what's your handle? Like, are you in the Discord? And then I was like, yeah. And we also gave out some cool t-shirts. So hopefully I can actually get that to a point where we can distribute the swag globally, ideally. But yeah, I'm kind of just trying to keep my head above water with how busy we are right now. So hopefully that'll be a future project that we can do. But yeah, we gave us some cool t-shirts and some cool stickers. So yeah, it was super cool seeing everybody. Okay, so let's see what was up with this. 49. Oh, same thing as before. Okay, this is probably not the best way to do this, but you could see kind of what I was doing with Tony when we were doing the scavenger stuff. Yeah, man, Vegas was so hot though. It was like crazy. Basically had to like hide inside the whole time because of how hot it was. But aside from that, it was good. The Malware Village was super busy, which was really cool. We sponsored the Malware Village. I don't know if y'all know that. And it was really cool to see that because that was the first time that they ever did that. And a couple of my friends volunteered there. Got to meet Russian Panda over at the Malware Village, which was cool. And then, yeah, just got to see a bunch of friends as well. So that was really nice. Okay, I might just reanalyze this and then force the analysis with the function size because this is taking forever. So let's see if we can do that in a separate window. B4A, just want to make sure that B4A. See if we can force the... This is all good to know as well if you're like troubleshooting binges stuff, so I don't think this is a super big waste of time. Max function size, so we'll just set this to like 65K. Let's just make it like 655K, and that should fix that. That's going to take a while to load, but yeah, this is still analyzing. 1 gazillion. Oh, does NPOV, does that work? Just setting it to 0? Yeah, this is taking forever. I tried to do this ahead of time, but another thing that you can also do is from this headless script, I could do something like, I think like bb.save or something. I can't remember. Binge API. Get at these hotkeys. I know there's a way to save this to a file. Let's see, is it in this gist? No, I think it was just the saved attribute. But yeah, I know this is possible. A while, so we might as well keep looking at this. Let's just look at the API. Save, binary view.save. Saves the original binary file. Okay, that's not what we want. Do we have a different type of save? Create database. Oh, cool, yeah. So I think that should work. So if I do like this and then bv.save database, and then we'll do like binary, we can do .bnb like that. That should work, I think. And if we do the I keep forgetting the hash, B4A, let's see if that works. Yeah, we'll disable small note about the setting 0 above the flag in the UI. Might be nice to also set setting comments. Might be nice to also set a tag. And oh yeah, for some reason I misread that. Is it just set tag? I actually don't know the tag API very well. Let's see. I'll obviously look that up. Yeah, tags would be cool. It's a class or tag object. One footgun with tags. So you can set a tag twice for the same instruction. Okay, yeah, that's good to know. I usually wrap it with an add unique tag sort of function. Yeah, that makes sense. Just add tag. What? Didn't I just look up that API? Okay, well, let me find that. Let me just figure this out first. Create database. Why did I just fudge that? But yeah, let me try adding the tags too. While it's running, I'll just open this in a new. Actually, I'll try from the UI first. And then we'll do like test. Oh no, that's creating a new tag type, right? I don't do that. I just want to do add tag. Okay, and then we have the address. But yeah, you're right. We should probably do a unique sequence for these. Probably both of these because I was getting comments. Yeah, I know. I should probably use NeoVim instead of just Vim. Let's do add comment and tag, or add comment tag, or deobfuscated string address. And then we'll have, and actually let's just make this a list. We'll do, and then we'll do this. We should probably have these backwards, and then that'll be add tag. I just need the rest of this too. But okay, so I think this should be done. So let's run it in here just so we can get this moving, and then I'll add the additional tag functionality while this is running. And then obviously it's really nice that everything in Binge is like multi-threaded and blah, blah, blah. So I could just do like all this stuff while other things are running, which is also a good way to run or write your plugins. Okay, I need the docs because, okay, here crashes. So the tag type name, can I do like get tag types or something? Type, I don't know the names though. let's look. Like, do I have to use, what's the names? Get tag type name. I usually use fun emojis for my tags. Yeah, it's a good idea. I think Python, like, can this just be any name? I guess so. It's just a string, so I'll just do that. So I'll do, let's do, what emoji do you guys think we should use? Evil. I just need this guy from somewhere. Knife emoji. Yeah, I like it. I like that better. It's so stupid. And then say we'll put the deobfuscated. Oh no, wait. This is the. So would that be? Okay, I will put the deobfuscated string in the data, right? Yeah, we need the address first. So this will be the address deobfuscated string. I copy paste emojis into the second arg. Yeah, okay, cool. And have a name in the first arg. So I remember why I added the tag. Oh, like will this look weird if I do it this way? Let's just test this in my console here. And go to tags. Did that not work? I don't know this API. I guess it didn't work. Why wouldn't it tell me that it didn't work? Oh, oh, sorry. It was the error. Test. Do I have to create the tag type before I can use them? Do I have to use important? I just don't know if I need to make a tag type first. Oh yeah, I do. Okay. So create tag type. Okay, and then okay, let's do that first. And then string icon, let's see here. Okay, so then we have the name will be deobfuscated string. And the icon will be the knife. We'll get rid of this. Okay, there we go. And then we'll try the custom type again. Yeah, cool. Nice. Now we have knives and our tags here, deobfuscated strings. Perfect. Okay, so then we'll do that here. Here, I just want to screw this up, so I'm just going to grab this again. Yeah, this is sick. Okay, and then we just need the deobfuscated string. Deobfuscated string. Okay, and then I actually think it's okay if we add it. Oh no, so you said it because it can be the multiple tags of the same address, so I guess we should make a list. And this will actually be a dictionary. And let's just say deobfuscate string like that. And then we'll pass this to our add comment tag function like that. And then we're going to save the database after that. So hopefully that all just works. And then I can just open up the database with this stuff already done. But we do want the, okay, let me copy this out again. Rust Binge script one. Yeah, I think Rust is a little bit harder because I think you have to recompile the plugin every time you want to use it. So it doesn't make for a very good stream experience. Haskell Binge script. Yeah, you should write the Haskell bindings and POV. Okay, so let's get rid of this. Actually, I want to try like the end-to-end saving database thing. I don't even know if I tested that yet, but let's try it. B64, right? B48. I just need this. Oh, let's see if that works. Cool, that did work. Hell yeah. All right, I'm just going to RM this because we're going to have our new database with all the tags and stuff. Well, hopefully it works. I should probably test it first, but I'm just going to assume it's going to work. And I'll share this with you guys later if you're interested in all these little tricks that I've been. Hopefully this just works. Ah, crap. I think I messed up the dictionary enumeration. Okay, let me kill this. It's going to be a waste of time. Is it enumerate? Can't remember. How do I flatten a dictionary in Python again? Items. Thanks. I always forget that. I don't know why. Yeah, cool. All right, that should work now. Hopefully. And then we'll actually do like real reversing after this. So just messing around with, I think this stuff is okay though, because it shows you all how the Binary Ninja API works. Because I don't know why, but even though I added that option to open it with that huge function size, this still didn't analyze. Is this function bigger than 655K? Potentially it is. Maybe it is. That'd be pretty insane. But yeah, I'll just do the 0 open. But I think our headless one is going to beat this analysis anyways. But we do actually need to 0. 0 disables this feature. That's what I should read, you know, instead of just doing things. And then what else do we have here? Deof strings. Okay, I think that should work. All right, it's a race between the UI binge and the headless binge. I don't know if I could set more cores for the headless binge too, though. I think I can. Let's see. I know there's like batch processing. Batch processing, Binary Ninja. But I think that was like a per sample thing. Let's see. Binary Ninja, load, update analysis false. Multiple files looks good. Parse basic headers or stop at major analysis. Single function analysis. Analysis hold. Alternatively, use add user function. That's cool. I definitely need to make use of some of these because parallelization, that's what I was thinking of. Multiprocessing, set worker thread count. So I think this is just when you want to use multiple files, right? Yeah, then you basically like have an async pool that you're feeding files to. That's still cool though. I should be using that for processing all these files. This guy's still processing. This is painful. What else can I talk to you guys about while this is running? Yeah, I got to meet Tony IRL. We hung out. Going on a tangent, but the trap 6 got me into a bit of a rabbit hole. How do you guys usually go on to find which trap number is what? So I think this might be a high-level IL thing, because if I go to the disassembly, it's a UD2, which I think is just a standard trap instruction. Yeah, it's an opcode. It's a valid but intentionally invalid opcode, meaning it is designed to trigger a sig ill instruction. Is that what you're asking? Set comment. What do you mean doesn't exist? Am I crazy? Why is that invalid? Alright, let's try that again. Alright, this is done. Let's see if this works. After we set the function size to 0 to basically disable the max function analysis. Hey Shusheng, how's it going? Isn't it like crazy late there? Or is it the morning? I also got to meet Shusheng in real life. Or well, for the second time. We met at Reverse in Florida earlier this year. He brought a bunch of binge stickers, which is cool. Alright, looks like why is this not analyzing? It doesn't make sense to me. Is there max HLIL function size as well? Probably. Oh yeah, Lopsec too, we met. Or well, I met at the Malware Village. His talk was awesome too. That's recorded, right? I think that was from your, let's see, I think it was at OBTS, right? Is this the one, was it 6.0? If you have the link to the talk, let me know, because then I'll throw it in the chat, because it was really good. Especially for a noob like me for macOS reversing. Yeah, this one, right? Or was this different than your talk at DEF CON? Anyways, I'll throw this in the chat. That was sweet. Okay, similar. Everybody check that out. All right, looks like our headless one actually worked. So let me open this. Oh, it looks like what's the opposite of headless? Headful. Oh yeah, let's see if our tags, or no, our tags didn't get added to this one, but let's, that was dumb. I should have done or I can add it now. Here, let's do that. All right, take care. Humpty, thanks for hanging out. Appreciate it. Okay, let's put this into Binja here, and then we'll actually reverse this, or see what we can find here. BV, this is all we need here. Shusheng, we're just messing around with this Deobfuscator that I wrote to analyze some other binaries that I found that was using the same Deobfuscator. So, or sorry, that was using the same obfuscator. Let me link this one, xorstr. It's like a C++ vectorized string obfuscator. And it was being used by some malware that I was reversing, but then I found a bunch of other binaries that were using it too. Yeah, let's get rid of that. We don't need this line. Okay, this should add our tags too. And then yeah, we were messing around with the like tag API, and I hadn't used that before to make this a lot more navigatable. And then this should be working now. And then, yeah, nice. So now we have like automated database generation using the headless mode, which is nice. And then, okay, while we're waiting for this, because it's taking a while, let's just take a look at some of the other samples here. Well, AssemblyLine cache, so I haven't run this in AssemblyLine yet, or like put Binja in line with AssemblyLine just because I only have a commercial license, but I'll check with the Binja folks if that's feasible. All right, so check this out. Our little tags are everywhere now. Hell yeah, look at that. These ones are obviously not working, but okay, failed to read peb. So this is probably the loader stuff. So we have like our little knives here now. Yeah, and we can jump to all those locations. Status access code violation 4053. I don't know why they would have hardware profile good. So this is like often used to identify the system. So let's check this. Oh yeah, rich query value. Okay, so this actually has like stuff we need. So let's go up to the high level intermediate language. Hey Shushang, do you know how I can make sure like tags are in the HLIL, or is it just kind of like I have to do the side-by-side thing? Or not tags, the comments. So like I'll show you an example. So like I can't see this comment in this high level IL, matter too much, but if you add a comment at the address that has an HIL instruction, it will show up. Okay. Yeah, I'll have to write something that'll be like, find the closest instruction. I don't think it's a bug, because like technically this instruction is hidden in the HLIL, which is why the comment doesn't show up. I think IDA does the same thing. I copy this. Oh yeah, that's pretty nice actually. Something like that. Oh, this is just the hardware ID. I've just never seen that ID conf thing. But okay, so let's call this. This is all going to be C++ stuff. Another thing that I wanted to mess around with, if we have enough time, is seeing if we can recover some of these C++ types, because this is definitely like hard mode, what I'm doing right now. And we could mess around with warp, which might be cool. Let's see if I can identify the C++ version used for this. What's probably the easiest way to do. I think it should be an assembly line. PE service. My session might have died. Let's see here. Visual Studio 2022. Okay, so I think that might be close to the version I have. Let's see. Because it would be cool to be able to recover the C++ types, so I'm not really doing all this by hand. I should have done this while I was waiting for the Binja databases, but whatever. Okay, let's do a console app, C++, Windows desktop, blank application, Windows desktop application, GUI, Windows RT console application. I just don't know what, let's see here. That's probably what we want. For more information, why didn't this work? Okay, let's just do a blank project then. I think I don't have the stuff we need for that. Yeah, I messed around with warp a little bit. Oh man, is this thing borked? What's going on? This template attempted to load component assembly. Okay, maybe I can just copy one of my existing projects. Console app. No, that's what I just tried. This is gonna have a bunch of crap in it we don't need, but create window, back. Because essentially I just want to use the STL. But let's see what we can identify in here with respect to the libraries that are loaded. So I know there's a bunch of built-in C++ types already, so we could probably use that to start. It looks like there was some bcrypt stuff that I just saw, concurrency stuff. So Binja does a pretty good job at identifying some of these already. Okay, Shushank says I have, and warp works perfect for me, but I'm totally biased. At least it is no longer naming tons of small functions concurrency. Yeah, totally. The call interdependency is a pretty unique feature from what I understand, if that makes sense. Like the GUIDs of the calling functions coming into play of the GUID signature. Okay, so it has standard IO stuff that's been identified already. Okay, maybe let's see, because even if I compile some STL template stuff, okay, this is boost as well. So this actually might be cdecal, allocators. It's like you don't really want to reverse any of the standard library stuff. So that's kind of what I was going for, but it looks like a bunch of it's already been identified. And, string, xq. Okay, let's continue with some of these strings or some of these tags, because I know the build stuff is going to be quite boring, but also important. Okay, so we looked at that, the system manufacturer. We don't need the snippets anymore. What's this big one? Okay, so this is all the anti-analysis stuff, it looks like. So VMware, VirtualBox, QEMU, parallels. So like, this is where the Deobfuscator screwed up. So there's probably some of these that I want to fix at some point, but these are all probably anti-analysis related. Guess parameters. Those little knives are actually really useful for spotting the deobfuscated strings. Any chance the warp API will move into core? I think it already is. Wasn't it with 1.0, Shushank? TCG, I don't know what this is for. Under QEMU, those registers will contain, looks like hypervisor Siganture related. Is this all in the same function? Looks like it. Innotech GmbH, I think this is another. All right, so let's call this function our anti-analysis. Let's see where this is called. Basically, I just want to find the loader functionality. So if we want to do that, let's see if we can find loader-related strings. Anti-query information thread. This is probably also related to anti-analysis. I think this is C++ string related. This is our resolved anti-query information function. That is concurrency related. Okay. I believe so. I gotta go. See you, Shang. Have a good night. Or good morning, whatever time it is there. I found warp.core.h, warpcore.h. Yeah, cool. Okay, so let's see here. So we have our access violation strings here. Security alert. Security alert pop-up. I really hope this isn't just like some piece of test software that somebody wrote. Let's see here. To broadcast thread. Create thread run immediately. This is probably standard C++ stuff, but this might be part of Boost. Let's see here. Okay, cool. So it looks like whenever it sees some of these anti-analysis tricks, or whenever it sees anti-analysis stuff, it will actually cause a pop-up. We could probably test that dynamically, but we don't really have to right now. And I just found that using that, let's see here. Sorry, I know the font's big, so it kind of makes things hard to read, but let's see if I get back to that thread function that I was just pivoting off of. Okay, they're doing some bcrypt hash stuff here, which is probably something we want to pay attention to. Object length, hash digest. They're hashing something. Oh, they're just hashing the hardware ID with, let's see, SHA-256. Let's see, let's add this. I just want to see what it does with that hash. It might be using that for machine identification, but this is a giant pain with all the C++. Okay, so here's that thread function I was pivoting off of before. I think this is just all related to the security pop-up thing. Yeah, so we don't have to pay too much attention to that. Okay, let's see if we can find some loader strings rather than the anti-analysis stuff. So it looks like it's resolving all these functions, I presume. So let's just verify that. So for example, this string is win32u.dll, push structure. Okay, so this looks like it's unpacking code. So see how it says NT create section failed. If I look at some of the strings, there might actually be interesting stuff. Security alert, maybe not. This is an interesting string that's not obfuscated that we can pivot off of though to find more of these. Plain text string, and then, all right, this is just all other C++ stuff, I think. And then I think this is more, let's see here. Okay, so this is also using curl. So we did look at this for the Scavenger stuff. So this could be related. So Humpty's gone, but he actually made a warp signature for curl. So, or a specific version of curl. So I'm going to try that. I think it's on my host. Let's see. Let me just copy it over to my VM. Bear with me here. Types. Okay, so I just need to apply this, I think. But let me open the BNDB to show you guys. And then I'll export a warp sig. I'll show you the whole process just so it makes sense. But basically what I was going to do with Visual Studio to get some of the other standard functionality in this, if I was able to identify it, was basically exporting a version with debug information or PDB information that could be used to create a warp sig. So that's what I'm going to do here with this debug version of curl. So if I go to plugins, warp, let's see here, create from files, from current view, then I'm just going to dump this into my local, I'll just put it on the desktop for now. Then it says generating signatures. It's doing that for 2428 files. So, or sorry, 2428 functions. So it's basically applying warp to every single function. And then it will give us a little report here. So warp uses GUIDs for identifying functions. So on the left-hand side, we just have a given GUID and then a function name on the right. So if I, and then apparently you can add notes, which is pretty cool. So if I go to, back to our database here, I should definitely save this working because we don't want to lose what we just did. And now if I go to plugins, warp, load file on my desktop, shouldn't this be, and then it should apply any matching signatures. I don't know if this is the same curl version, but let's just see what happens. It looks like it's reanalyzing a bunch of stuff, so probably identified a few functions. But yeah, basically the workflow for me usually is looking for things like strings and other common functions that have been identified by Binja's type identification that's built in, and doing stuff like that in order to potentially identify libraries that are statically linked against the binary, and then trying to figure out what version of library that is, trying to figure out what, not only the version, but what compiler it was compiled with in conjunction with the current binary being analyzed, generating, in this case, a warp signature. With IDA, it would be like flirt signatures, and then attempting to apply that against the binary. So it's kind of a strenuous process, but the good thing is that it gives you things like this. So on the left-hand side here, there is now all these curl function names that we've identified. So those were previously not identified. So if I go to the tags here, we should have a little warp tag, I think, that we could see what was applied with warp. Yeah, so like 1,200 functions were just applied with warp, which is pretty rad. So a whole bunch of standard library stuff. And then if I scroll down here, we can see all those curl functions as well. So like, and then even important functions like curl HTTP connect and stuff like that. So now if I go back, so I'm actually really curious if this is any way, shape or form related to the Scavenger stuff we looked at, just because that was the same curl version. At least it's close, because warp is pretty stringent in terms of its flexibility for function matches. So it was definitely close. Okay, so let's go back here. Okay, so this is NT-map-PE related. I primarily want to see what it's mapping. And the reason that I've just marked this as such is because it's NT-create section failed. So it's obviously calling that here. So this is likely NT-create section. Let's see how that's being resolved. Concurrency push. Let's see, is this a resolution function here? RAX. So I'm just trying to figure out where that global is coming from. Looks like it was concurrency push related. So it might be hard to identify. What does this do? Okay, this is part of the concurrency runtime. I don't know a ton about C++ thread concurrency in Microsoft Windows, so this might be a rabbit hole that we don't want to go down. Let's see what these are. Adjust token privileges. Yeah, I definitely want to figure out. Okay, so this is probably adjust token privileges. And I just really need to figure out how this push structured function works, but. And then this guy, what's this? Check remote debugger present, more anti-analysis, large anti-analysis. Yeah, okay, so this is definitely building a function table. It's just a matter of whether or not they're being used. So what I mean by that is, like if we look at this, and if we look at what this is, and look at this string, then this is, well, it's kernel 32, but let's see what's resolved before that. Get current thread. See how this obfuscation makes things a giant pain? Okay, that's not get current thread then. Oh man, this is so slow going. Every time I adjust these windows, it just like moves the subsequent windows, so then I lose where I was, and this is not great. Usually I'm running at like 4K, so it's not a problem. Okay, so I'll show you what I mean. So if we have get current thread, and then I go to this global here, then we can see this global is called here. And this is a reference to get current thread. And oh man, okay, yeah, there we go. Built-in memset, would that make sense? Let's see what this is. Get thread context. Yeah, okay, cool. So we're on the right track here. Yeah, essentially we can go through the rest of the binary. I'll basically be able to hopefully be able to find where this is loading something. We don't quite know yet what that is. And then we can continue with that. We can look at another binary. What do y'all think? Any thoughts, concerns? One thing I was going to check was if this has any resources. Using our AssemblyLine run here, it does have a resource section, and it has a FU section. 2 of them. And POV, so there's just like a whole bunch of those. If I go back to, so like these are all obfuscated with the same obfuscator, and I just identified it using that YAR rule that I was looking at earlier. This one. So I could look at another one, but it's probably going to be similar to what I'm doing right now. It's just painful because essentially it's me going back to where the string is deobfuscated, and then since the comments aren't being shown in the actually don't really need the HLIL, so why don't I just get rid of this? Maybe that'll help. Yeah, let's do it this way. Query DOS device. Okay, let's see where else this is called, because this will effectively be all the locations that these are resolved. When HTTP open, when HTTP connect. No, it's all good. Basically, I'm just like slowly working through this binary. I think if we can make some progress on this, that'd be cool. So when HTTP open request, would you be interested? Thoughts on from back engineering? Is back engineering collective or something? Yeah, let me finish this and then I'll definitely take a look. Is it a challenge, or I think it's just a sample of their bin to bin obfuscation. Okay, cool. Interesting. Okay, let me check that out real quick. So I'm like scrolling all the way back to the top of the chat. Oh, cool. Nice. Let's see what this looks like. If it even analyzes. Oh God. This looks bad. Looks like it's doing stuff. It's just like a JOP obfuscator or something. Are these all gadgets? UDT. Oh, it looks like she found stuff. Check out the tags. Oh, is there going to be like a ton of errors? Oh yeah. I'll just wait for it to be done though. Let's continue work here. All right, I'm just going to run to the washroom real quick because I haven't gone all stream. I'm just going to play a quick ad for our malware analysis training. So for those of you who are not aware, I am the founder of a company called InvokeRE, and we do malware analysis training, and that enables me to do these streams for free and all this content for free. We have like a YouTube channel where I post all these streams, et cetera, et cetera. So if you are interested in learning stuff that I'm doing today, we have a introduction to malware binary triage course. So it's just right here. So I'm just going to throw up a quick ad for that. And then I'll run to the washroom and then we'll just continue with this. So I'll be right back. Hey everyone, my name is Joshua Reynolds and welcome to the InvokeRE Introduction to Malware Binary Triage course. Throughout this course, you will learn to triage and reverse engineer malware binaries using a number of proven techniques. These include static analysis, which is the concept of analyzing malware at rest, and dynamic analysis, which is the concept of analyzing malware as it executes. We will also be analyzing network protocols used in malware command and control communications, malware obfuscation, packers and how to unpack them, process injection, how to write effective YAR rules to detect malware variants, and how to compare malware samples at a binary level. This course consists of 11 modules, each containing lectures and practical labs to apply knowledge that you have gained as you complete the course. We provide both video and written materials, so no matter what your learning style is, you can complete the course successfully. Thank you for checking out the course, and we look forward to teaching you. All right, how's everybody doing? The jumps just crash IDA. There's a CVE for them. That's crazy. Let me check out Binja. Oh yeah. Is it a DOS CB? Nice. Well, good job, Vector35, for not crashing like Ida. I got another coffee and some Oreos. All right, let's go back to... Yeah, it's weird that you say that, because that's what this is. It's like the little headphones. Yeah, it tastes like... Do you ever eat Dunkaroos when you were a kid? For those of you who are not North American, there was like these things called Dunkaroos that you would basically dip cookies in icing, and that was like a kid snack. And that's basically what these are. You'd fun dip. Yeah, fun dip's pretty good too. Again, just dipping sugar into sugar, basically. But it was pretty fire. Looking in the tags. Did you reverse IDA to see what the crashes were? The first thing that I would do with this binary is run it through time travel debugging to get the trace. But I guess this is a mem copy. There's some weird instructions in here though. This might not be valid. Like what is, I don't even know what this is. It might be a privileged instruction though. Oh, never mind. It's just some X 64-bit instruction I'm not familiar with. Okay, should we continue with the malware? We could probably do this crack me on a different stream. Looks like there's a whole bunch of invalid instructions like this. Cannot generate the IL flag. This is even lift. Yeah, but it looks really gross. What does that jump table look like? Decompiled. I don't even know if it'll work. Their bin does a lot of weird instructions on purpose. Yeah, that makes sense. I'm just going to continue marking these up. When HTTP read data. When HTTP close handle. Here we go. Some like process enumeration stuff. This is probably has to do with the unpacking or the loading. Process 32 first W. Crap, what did I just do? But y'all get to see what real reversing looks like. It's not like the movies where things take 3 seconds. Although I try and automate as much stuff as possible, but we already like automated a bunch of that. Process 32 next W. Close handle, which is used in a bunch of places, which makes sense. Okay, let's see what this one is. Open process. What was that? Man, this UI being this big is really annoying. Okay, 32 get module file name XA. Get current process ID. Hello, gangsters. Quick question. What's up, Cyber Swifty? Yeah, it'll be up on our YouTube channel. So we have, if you go to invokere.com, there's like a little YouTube link here, but if you just search invoke reversing or invoke RE on YouTube, you'll find our YouTube channel. So it won't be up right away just because we give early access to students and stuff, but it'll be up probably in a week and a half. Righteous. Yeah, no worries. I think a lot of folks are still working. It's like 4:30. Create thread, sleep, get current process, get tick count, 64. So usually get tick count is used to identify like debug timing differences as well. Let's see here. Virtual protect, virtual handle A, virtual alloc. I wish it would highlight like which of these I was currently at. 551. Like why can't I? DD 551. This one. Virtual free. This is painful. Almost there though. Get proc address. All important unpacking stuff. Load library A. Get module file name. DE 2A7 A3D. Create file W. Get file size. Now we're into advanced API. Open process token. Yeah, this is pretty crazy. Open thread. DFFB9. Okay, maybe let's pivot to looking at some of these resolved functions and seeing what they're used for, rather than me just marking these up all in stream, because I know this is getting pretty boring. If we hop to these, so you can see that like this is we still have quite a few functions that need to be resolved, but this is effectively building a function table at this address. So that's effectively what I was doing. I was going through and marking up all these areas, or all these global variables rather, for their dynamically resolved functions. And then if I highlight any of these now, you can see, okay, like get process 32 next W is being used in this anti-analysis function. And then if I go to the high level intermediate language, for example, then we can see, okay, this is calling process 32 first W. And if we look up the docs for process 32 next W, then we can see that this has the H snapshot and then the pointer to the process entry 32W. So then we can just like mark those up, for example. So snapshot and then our struct, or let's just say proc struct. And then let's see here, finished enum. And then we're acquiring the type of snapshot here, which if I look that up, then we could see this is the process ID. Let's see here. I just need the constant for the flags. th32. Hopefully this is in Binja. Snap process. So basically this just gets a process snapshot of all processes running in memory and then enumerates that here. And then if we have, let's see here, it's doing a string comparison with the, I just need the correct struct here. So it'll be a process entry 32W. So like that. I might need to adjust that one more time. exe file. Yeah. I don't know what just happened. Okay. We don't want. It's probably just enumerating the exe name. Let's try it again. So let's make that a pointer. Count usage. Let's see here. PID. Okay, so yeah, there's a whole bunch of like pretty standard anti-analysis stuff. So it's like acquiring the get free disk space. It's doing a string comparison for the, let's see here. This might be a pointer to a pointer. That's automatically, or what was automatically identified by Binja anyways. Let's see what the struct looks like. Yeah, I was expecting it to have the zexe file as a part of this field and then doing a string comparison with that. So current process and then target process, or let's just say target exe. And then this will basically just look for a certain executable within the running processes, which is probably up here, which we did not decrypt properly, but that's okay. It's probably looking for VMware related processes or something. Okay, so if we go back to the HLIL, okay, so if I go back here, let's see what other interesting functions are being used here. So it should be get module file name W. Okay, so this is basically walking the PEB, getting the module name of the current executable, getting a handle to that, getting the size, reading that file. Let's see what this is. It's used a lot, so we should see what this is being resolved as. I have to do the same thing again. Memcopy. Failed to read PEB. Okay, let's look at the docs for read file. Should pop up as the first thing. To the buffer as the second parameter. Okay, it looks like they're getting, I want to make sure I understand this correctly before talking about it or explaining what I'm thinking. Okay, get module file name. Okay, it iterates through every single module on disk. I think this is basically just reloading each dependency into memory. So this is like a common technique that's used to avoid hooks. So I'm just going to add a tag here if I can. And I'm just going to call this important and then reload module dependencies. So this is commonly done by malware just so they can completely avoid hooks in memory by overwriting their original DLL dependencies with the ones from disk, which will effectively not have userland hooks in place that are commonly set by antivirus, etc. So let's see what this is. Oh, this is painful. Like every time I switch from, this might be a bug. So get proc address. Okay, so let's look at this again, because I think this is mapping the text section for each of these dependencies. It's probably just another STL dependency, or not STL, but standard Windows library dependency. NTDLL, let's see, memcompare. All right, yeah, so I think they're just doing a section by section comparison as another anti-analysis trick. Okay, let's see what this stuff is doing. Failed to get loader data. Okay, so that's obviously important. Let's go back in our tags here and go back to that. All right, so this is the fail case. So let's take a look at, is that just when it can't get access to the PEB? All right, let's see here. GS60 jump not equal. RAX. Yeah, so that's just when it can't get access to the PEB. And then when it does get access, then it looks like it's okay. So what I probably need to do is fix some of these, because it looks like, for example, this is not loaded properly. I might look at some of those interesting sections though. But before I do that, let's go back to our globals and see if there's anything else that is loader related from here. Okay, so this is all, I'm interested in this anti-analysis trick. Let's see, get process memory info. So let's see, memory counters. Oh, hey, Payne Kapanko. Thanks for the raid. I really appreciate it. How's everybody doing? Hey, the Shy Hat, what's going on? So just to kind of get everybody up to speed, actually before I mention that, let's take a look at Payne Kapanko on Twitch. What were you guys up to today? Anything interesting? Yapping, dumpster diving, hacker gremlin, of your nightmares. Nice. Hacking Kubernetes stuff on Hackthebox. Nice. Awesome. So everybody, for some background, my name's Josh. Today I'm using Binary Ninja to reverse engineer some highly obfuscated malware. So I'm sure most of you are familiar with what the concept of reverse engineering is, but for those of you who are not, this is a reverse engineering platform similar to IDA or Ghidra, and I'm basically using it to analyze this loader malware that is probably being used to load another payload into memory. So that's what I'm doing right now. It's pretty slow going just because there's a bunch of what I said, obfuscation. So basically all that means is there's like jumbled instructions that make it hard to analyze. So I'm working through those instructions now and seeing what I can glean from the binary and then seeing what we can get out of it. So thanks everybody for hanging out though. I appreciate it. So that's a pointer, or that's going to be the tick count. And this is Microsoft Windows malware. So let's see where else this is used. This is probably another anti-analysis trick. Let's see here. Yeah, this is probably original tick count. And then is this, where's this set? Let's take a look. Yeah, so that's looking for a 60 millisecond tick count difference, it looks like. And then let's see what else. This is probably the failure label, status violation. So yeah, it's all timing related stuff, it looks like. Is this what's checked for every single time the security pop-up is made? Yeah, it looks like it. So basically this program is essentially like protecting another stage of program. So it's kind of like, if you're familiar with like DRM, that's often used by applications to protect themselves against reverse engineering. This is doing something similar. So show, okay, let's see here, get module handle, find a flush instruction cache. So these are, let's see if I can display them properly, MZ and PE. And this is using get module handle with the null parameter, which will acquire the current process that's running in memory. So this is acquiring the text section of the current process, and then it looks like it's comparing that to the value of 5. So I don't know if that's often a hooked value, but, and then this is calling this recursively. Let's see if that's actually what this is doing. Also, I don't know if you're still around, but were you able to solve the Kubernetes box and hack the box? Okay, so this is making a NOP sled for a given function. I stream until I solve it, or I have to dip. Okay, nice. That's sick. I definitely don't know a ton about Kubernetes. Is there anything in particular that makes an instance vulnerable to attack, I guess? Okay, let's keep going. The string comparison is actually for the text section here. Normal configuration and containerization stuff with added cloud API stuff. Yeah, okay, that makes sense. Yeah, I haven't really done a ton of Kubernetes work, but it seems like it's super complicated and rife with potential for abuse. Yeah, there's definitely overwriting a particular part of the section because it's making this read write execute at the LP base address, and then it's acquiring it from this offset 28. So I don't know if this 28 is the start of the section data or the start of the section address. More patching, it looks like. Okay, let's see. This might be mapping related. Unless this is just done. Yeah, I think this is just done this is probably for anti-analysis stuff. So essentially if it hits the anti-analysis case, then it will show that security pop-up and then sleep for this amount of time, so 500 milliseconds for whatever reason, and then it will overwrite, I'm guessing overwrite the text section, which is what we're looking at right now. So pretty interesting. Abort. So like a lot of unpackers, for example, will wait until the process exits, and then it will dump the memory at process exit in order to try and see what's in memory. So that might be the reason for doing it in this case. So we continue looking at some of those APIs. Let's look at virtual alloc, because that's usually pretty indicative of unpacking or mapping. Okay, this looks like mapping code. Man, the way the text, like in the high level intermediate language view, the way the text will change as I resize the window makes this like very difficult. Okay, current thread. Let's see, where was I here? Check remote debugger. So this all is still anti-analysis stuff. Okay, read file. And again, this is portable executables, headers, and then it's mapping the text section, our data section, or it's looking for those sections rather. So the our data section might be important in this case. Okay, let's set a little tag here so that we're not revisiting this over and over. So I'll do add tag, map file sections. And then if we see where this buffer is coming from, it's performing create file on this, which is just a backslash. It's probably bigger than that. It looks like our little deobfuscation sequence didn't work. Okay, this is probably important. So map file bool. That might actually be because of, let's see if I can find this in the output file. That might be because it's a Unicode string. Oh no, it's actually, we just want result. Yeah, okay. So we actually need to, in order to fix these, we need to remove the null bytes in our little script here. So let's do that because that's really important. So let's, where's the resulting string here? Our string. And let's remove the null bytes from this. And I think these will be strings at this stage. Our string, yeah, we're decoding as ASCII, so it'll be a string at that stage, or a null byte like that. So let's rerun this, because we definitely need those Unicode strings, and then I'm going to see what buffer this is. Oh yeah, this is mapping NTDLL. So that makes sense, because getting the system directory, and then we have the, yeah, so it's basically, I think this is all anti-analysis stuff. So let's see what else virtual alloc is being used. Okay, let's see. Read file, get file size. Okay, let me double check our AssemblyLine instance here. I'm just checking if there's like anything in this section that's of particular interest, but not really. It looks like encoded data, but if I go to sections here, there's two our data sections, so it's definitely interesting. And a resource section. Okay, so this might be the our data section that they're deobfuscating. So this is probably the payload. So if I go back to our tags here, there's two our data tags. So let's see what this is used for. I'm just trying to figure out, okay, here, exactly what this is used for. So if our data section, mem compare. So if this is true, then this is probably the data. And let's see if we can figure out how this is deobfuscated. Okay, this looks like a potential sequence. It's just an OR sequence. Here, let me switch to pseudo-C to make this more readable. All right, so what we can probably do is see if we can deobfuscate this dynamically, because I think this is a little bit too complicated. But the only problem is that we're gonna have to get here without hitting those anti-analysis functions, which there's just like a lot. So let me see where this is called. I'm gonna add another tag as important. Okay. And then let's see, B8, wonder if that's in here. This definitely looks like an encoded PE, but I'll have to C3. I just want to make sure it's just not that OR sequence. This OR one is what I was thinking. While true. All right, let's see how far down this is. All right, let's see if I can get to this. When verify trust, is this being used for the signature? Trust action on the specified object. That's kind of cool. So probably verifies the signature and then gets to that point. So how many anti-analysis steps are before this? Probably a lot. But I wonder if we can just skip them entirely. Yeah, this is like, all right, well, let's give it a try. And if this is too hard to get to in the obfuscated binary, then we'll see what else we could do. I'm just going to restore my snapshot for this VM I'm working on. This is the VM that I'll use to run this dynamically. How's everybody doing? I appreciate you sticking around for this stream. I know working through a lot of this obfuscation has been painful, but it's a good illustration of like a real world scenario that it's sometimes pretty difficult to get through some of this. So I'm just getting this binary over here. All right, so this is my dynamic analysis machine. So again, we can double check by right clicking on it and looking at the details in digital signature that this is indeed signed, which is quite interesting. And this was signed on May 26th. So quite recent. This is 64-bit binary. So we need to use x64 debug. And then we need admin privs for the binary. Okay, and then it looks like it's a console app. So it's just opening the little window there. And before I run this, I'm just going to take a snapshot and kill my shares. And we'll see how far we can get with this. I guess the x64 debug font's really small, eh? Let's see if I can make that a little bit bigger. And then let's see what else we got here. So let's go to the entry point. And then we have that UD2. Fortunately, I think my debugger exception is not set to that. So if I look at the, let's see here. Yeah, so if I look at the engine here in x64 debug, there's the default breakpoint type, and it's currently int3. So I don't think this UD2 should do anything, but we can just patch it. Looks like it is causing an exception. So we can just do fill with ops. We skip over that. And the thread's already running. There's probably a lot of tricks in here that I haven't covered in their entirety in the static analysis we're doing. This is actually doing anything. Maybe filling the current breakpoint with nops is not great. Okay, let's try this. Before I hit that system breakpoint, let's go to, before I hit the original entry point breakpoint, let's make sure I patch that. So let's see if we can line up these addresses here. Okay, I'll just do this real quick. So I'm just going to grab the base address of this loader, copy address, go over here, rebase our binary here, and then go back to our binary here, go to our address of entry point, which is not here, go to the triage, our UD2, so I'm going to copy this address. Let's see if this fixes it. Patch that, binary, fill with nops, breakpoint, set hardware and execution. Let's go there, debug stopped. All right, let's see what it does. One of the, do we need to restore? Oh, did it patch it? Yeah, let's restore a snapshot. And I'll adjust the font size again for everyone. And I'll take a snapshot so we're not doing that again. Okay, and what I might do instead, take a snapshot so we don't have to do that again. And I might just patch the entry point on disk so we don't hit that. So I'm not having to do it at runtime. All right, let's try that. So kill this. Then we're going to, we can just use, I don't know if we can use IDA for this actually, because that's IDA free. So let's use Binary Ninja on here. Okay, let me see if I can patch it on the other box. Or maybe I can do it on here without having to wait for it. Convert to NOP, export, let's see, and changes to the automated analysis have been made. Okay, let's see if that works. So the loader actually verifies the integrity of the binary on disk. So me modifying that might mess things up, but let's check it out. I just want to check if this is actually a different hash, that I actually saved it properly. It's still valid. And then we want hash my files and the SHA-256. Yeah, it's different. Okay. So let's load the patched one, which we have here. Then we have the no ops now. Okay, so that fixed it. So if you see that entry point function there, and you have a UD2 at the address of entry point, then a good hack is just patch it from disk, and then you can get past that. So if we go to, let's see what else we got here. Let's get out of our single function view because this should fall into here. And let's see what our anti-analysis function is at. So let's rebase this again, just so we're all on the same page. And then let's go to our, hey, how's it going, NPOV? Thanks for coming back. I'm still working on the same sample. I just patched this UD2 entry point within the binary so we can debug it. Let's see if we can get to this large anti-analysis function. So I'm curious if when all those functions are resolved. Yeah, no, there's a lot of profanities in this. Let's go to that push function. Okay, so these are, like, where are these resolved? Let's just get to the start of this function, because this is let's go back to single function view, and we want to go here first. Okay, let's see why that happened. We might not even get to our start function before we hit anti-analysis stuff. All right, let's try that again. All right, what's the decrypting here? Let's see, what is this? I think this is just cookie stuff. And by cookie, I mean security cookies for verifying that there's process integrity for anti-exploitation stuff. All right, let's see what this is. Okay, what I'm curious about is whether we could jump to the start function, but I prefer not to do if possible. Let's see here. Why is it exiting the thread right away? Does this have an export? I think this is the export. Actually, we need to, yeah. Even though this is like a portable executable, sometimes you can actually just force it to be, while also having an export. So x64 debug basically needs the correct flag to know that it's a DLL for it to be loaded as such. So I'm just thinking that we could probably set that flag ourselves. But let me just see if we can force it to jump there, and if that will actually not mess things up. Okay, what's this first function here? Check stack. Okay, so far so good. All right, let's go into this first function and see if we can decrypt these strings and stuff. I don't think this is any anti-analysis stuff yet. I think this is just loading libraries. We shall see. Okay, so this is a good opportunity to show you guys what it looks like in real time to see these strings being deobfuscated. So like these are moved into RAX and then moved onto the stack. And then we should see the deobfuscation sequence here. Yeah, so this XOR, should see this here, load library. So like that's basically all it's doing is these XOR sequences, pushing them onto the stack and then perform the XORs. So I'm curious if we can get to the point where these are all loaded, but let's this functions. And then, because I think a lot of these are called later on, I just want to see if there's any anti-analysis stuff in this function. Ooh, what's this D39? So this is basically going to like ensure that all these functions are in memory. So I'm just going to let this run IVM. There's an access violation for some reason. But you see like all these libraries were deobfuscated in memory, which is used by the malware. Block here. We might have hit one of the anti-analysis checks. Okay, what I might do is just make this a DLL. I just can't remember. Can I use PE bear for this? Let's see. There's a lot of effort to just get to the second payload. But I guess that's what we signed up for. So export directory. I know there's a application to do this. Let's see if I can, that is. I think it's a Didier Stevens thing. That might be ASLR, sit DLL characteristics. I know you can do this. One bit is different in the DLL characteristic. Okay, I might be able to use that. Didier Stevens, dynamic base, force integrity. I think this is all related to ASLR and the security bits though. Let's see what we have on. We have DLL to EXE, not EXE to DLL. So what I'm not sure about is, because I forced it to go to that export, like as if this can run on its own. Okay, let's just restore that snapshot. And I want to take a look at some of the dynamic stuff. And we might revisit this next week, just because I've been streaming for like 4 hours. I wasn't really planning going past that. But before I stop, I know this is probably not very complicated. I wanted to take another quick look at that tag and then see if we can. So like basically what I would do next is set the DLL characteristic to be a DLL instead of an executable, and then go through the anti-analysis checks and then bypass them, Doing that manually will take a lot of time, but there's ways that you can get around that within a hardened environment. And then once those are bypassed, then I would let the binary run this deobfuscation sequence. But I can't let the binary run this deobfuscation sequence without having those libraries mapped. So I was hoping that those library mapping functions, which are performing those XORs and then resolving the libraries in memory, would run before the anti-analysis checks. So basically I could skip over those entirely while having the libraries that are referenced in memory properly. So what I can probably do is figure out an approach for this for next week, and then we can revisit this and finish this. But yeah, there's a lot at play in terms of the mappings that I want to finish marking up in this database for the function mappings that are done dynamically in runtime with these XOR sequences, which is quite boring to just do on stream. And then 2, essentially figuring out how to get to the point where this payload is being deobfuscated. So there's a few different things I want to try. I could probably get those handled before next week, and then we could probably revisit this. What do y'all think? But before I go, I was just going to take another stab at the deobfuscation sequence here to see if I can figure out what's going on. But yeah, this loader is like pretty nuts. Okay, let's see if I can get the... So this would be the section name. The pointer is this. P header. So this should probably be part of the section header. Let's see where the... let's do it not here. All right, let's try image section header, because this would be the... So I think this would be times 28. Oh, this is the MZ, or this is the image optional header. This is the image DOS header. Yeah, so this is basically walking the headers, I believe. And then this is index, section index. I don't know why it's not renaming. There we go. Piece of code, our data section pointer. Yeah. Okay, so now we have the pointer raw data. Our data raw pointer. Let's just call it that. If it's not 0, then this is gonna be the, let's see here, virtual address, physical address, plus 20, and then we're moving through the section. I just need to see where it's deobfuscated. All right, so while true, CI is this just the current byte? Okay, so it's just adding, this is the current index, right? The raw index. I'm just putting like actual pointer because if it's not equal 0, CI, so it's definitely the index. So it's looking for this B8 value within that resource. It's also getting the pointer plus the index plus 1 and assigning that to this value. And then it'll break out of that loop. Then the C++ function, hash array. I think this is just an exception. Yeah, I think this is C++ related. Okay, and then RAX, let's see. All right, this is but the file being read from disk is okay, this concatenating the Windows directory. Let's just ensure that's actually the case. Okay, ntdll. Yeah, I think this is just another anti-analysis check. And then this our data sequence. Okay, these are the same. So why it's reading the R data section from ntdll on disk, I'm not entirely sure, but that's all it's doing there. I was hoping that was the R data section of our portable executable, but let's see what else do we have here. I want to take a quick look at the other data types. So map file sections. Oh, that was R tag. Okay, let's take a look at ntn map view section. Got it here. All right, I need to figure out how to get the comments in the HLIL, because this is very difficult. Once I have it on like a full screen, it should be a lot easier too. So yeah, why don't I take this away, and we can revisit this next week, and I'll show you all what I find. But I think we're probably done for today, and then yeah, we'll see what this loader is exactly doing. But we got pretty far. It's essentially just to the point where we're trying to figure out the unpacking sequence. I could probably also work on getting those templates loaded properly in Visual Studio so that we can resolve some of the C++ stuff with Warp, or even more stuff with Warp. Tanto could be a nice view to look at. Let's see, Tanto. That's Binary Ninja related, right? Yeah, the slicing stuff. Yeah, cool. Yeah. For the code, yeah, and POV, are you in the Discord? I'll upload it to our GitHub. If not, I'll link you here. I'll just throw a link in chat for everybody. All right, there's a link to the Discord and POV. I'll shoot you the code on there if you can join. This recording will be up, yeah, probably sometime next week, and then we'll finish this thing up. I just don't want to like spin our wheels too much. It's honestly really hard for me to see the entire UI when it's big like this. So I feel like I'll just be able to wrap things up a lot faster when I'm not moving these windows around. The HLIL moves around, like it's just horrible. So yeah, so let's find somebody to raid since we got raided today. Let's see, InfoSec streams. All right, let's raid Fixit42 because they often raid us if they're around. Okay, cool. Let's do that. Thanks, NPOV. Yeah, thanks for hanging out. I really appreciate you sticking around. So, all right, I'll kick off the raid. Thanks everybody for hanging out. Definitely check out Invoke RE if you're interested in learning how to do this stuff. And we'll see y'all next week. Have a great week, everybody. Take care.